Let's now solve a full quadratic pattern question. So we're given our pattern here, which is 3, 7, 13, and 21. We need to determine the next number in the pattern. So we know that this is not an arithmetic pattern, because if I quickly work out the first differences, I'm going to see that 7 minus 3 is 4, and then 13 minus 7 is 6. So that is definitely not an arithmetic pattern, because we don't have a constant first difference. Is it a geometric pattern? It doesn't look to be like a geometric pattern, because I'm not multiplying by the same number all the time. So we will try to see whether it's a quadratic pattern. So remember, for a quadratic pattern, you need to have a constant second difference. So let's try that. 7 minus 3 gives me 4. 13 minus 7 gives me 6 there. 21 minus 13 gives me 8 there, and we'll leave it at that for now. So that my first differences are 4, 6, and 8. Let's work out my second differences. 6 minus 4 gives me 2, and 8 minus 6 also gives me 2. So I know that this is a quadratic pattern because I have a constant second difference of 2. So to find the next number in the pattern, I know that my next constant second difference will also be 2. So I need to add 2 to the 8 there, and that gives me 10. Then I need to take this 10 and add it to the 21 on top. 21 plus 10 gives me 31. And this here is my next number in the pattern, 31. Let's determine the nth term of this pattern. We know that it's a quadratic pattern, so remember, to determine the nth term, you need to circle each of those first terms. The first term in the given pattern, the first term in the first difference list, and the first term in the second difference list. And you need to set up these small equations. So 2a is equal to the first term in the second difference list, which was 2. So if 2a is equal to 2, solve for a, you'll get a is equal to 1. Then you need to set up your second equation. 3a plus b is equal to the first number in your first difference list, which was 4. So 3a plus b is equal to 4, but we know that a is 1. So instead of a, we'll substitute 1. 3 times 1 plus b is equal to 4. Solve for b, and you'll get b is equal to 1. And your third equation, a plus b plus c, this is equal to the first number given in the pattern, which was 3. We know that a is 1, we just solved it. We know that b is 1, we solved that. And c, we need to calculate now. So c is equal to 3 minus 1, which is also equal to 1 in this case. So our a is 1, b is 1, and c is 1. Substitute that into our general formula for a quadratic pattern. So a is 1, b is 1, c is 1. So you'll end up with Tn is equal to n squared plus n plus 1, and that one will be your general formula of this quadratic pattern. Third question, what is the 50th term in the pattern? Remember, when they're asking us what a specific term will be, you need to substitute the value given, which is 50, in place of n. So wherever I see n, I will substitute 50. So T50 will equal to 50 squared plus 50 plus 1, and on your calculator, that's going to give you 2,551. That will be the 50th term in this pattern. Will 57 be found in this pattern? So remember, this type of question, you need to substitute the value given in place of Tn. So instead of Tn, we substitute 57. So we'll get an equation that says 57 is equal to n squared plus n plus 1. You need to take your like terms over and put them together, because this is looking to me like it's going to be a quadratic pattern that we need to solve, that we know how to solve. So 0 is equal to n squared plus n plus 1 minus 57 here. 1 minus 57 gives me negative 56. So 0 is equal to n squared plus n minus 56. Now I can use a cross method here to solve trinomials. We've done this before, so refer to that if you are unsure how to get these two brackets here. So 0 is equal to n squared plus n minus 56. Your two brackets are going to be 0 is equal to n plus 8 and n minus 7. You need to take each of those brackets, make them equal to 0, and solve for n. So n plus 8 is equal to 0, which means n is equal to negative 8. Now n cannot equal to a negative number. So we need to say that this one is not applicable as an answer. If n minus 7 is equal to 0, n is equal to 7. This is the one we can take because n in number patterns can only be a natural number. So 57, yes, will be found in the pattern, and it will be the 7th term in this pattern.